Wow, I don't know about you, but I found those stories from the keynote inspiring. People doing the hard work to address climate change, helping us to understand exactly what's happening, developing innovative solutions, and finding ways to drive down the cost.
And as Tanya talked about, MATLAB and Simulink were used in all these stories. So how is it that these products can have such an impact on the work of so many engineers and scientists? Well, much of it's because thousands of people at MathWorks are constantly working to improve the capabilities of MATLAB and Simulink with 2 releases each year. So welcome, everyone. I'm Michael Carone.
And I'm Heather Gorr.
Over the next 20 minutes or so, Heather and I will share some, but clearly not all, of these new capabilities. We know you'll find at least a few to be excited about and apply to your work. The talk is divided into 3 main sections. The first aligns with the research theme from the keynote, typically a time where you're doing a lot of design exploration. The second section is about scaling up your work and collaborating with others. We'll also discuss sharing your ideas in different forms so that anyone can take advantage of your hard work. Now, something that stuck with me from Tanya's keynote was when she talked about the uncertainty of exploration. We try different ways to smooth data, tune parameters, and generally just explore the design space. MATLAB and Simulink support this with interactive capabilities that let you focus on your work, not the tools.
The Live editor is a great example of this. A notebook environment that helps you quickly explore your design space with interactive controls and embedded outputs. You can also use Live editor tasks. These are small apps that you can embed right into your script that do the coding for you. Thinking back to Tanya's keynote, maybe we want statistics related to air quality based on a location. The compute by group task will come to the rescue. You select the groups, the variables, and which calculations to apply to each group. And you do all of this without writing any code yourself. Of course, the task will automatically generate the corresponding MATLAB code for you, so you can reuse it later. There are dozens for common tasks like data cleaning and design work, the sorts of things you tend to experiment with and try different techniques, like smoothing, resampling and synchronizing data, clustering, and more application-specific, like controls, predictive maintenance, and filter design. Live tasks aren't the only ways to interact with scripts. We mentioned the interactive outputs. You can now animate outputs with playback controls, then save it as an animated GIF or a movie file just with one click. This makes creating and saving animations much easier, especially if you've ever had to capture frames in a loop like the old days. So we talked about tasks that clean up your data, like smoothing and resampling, but often you want to do all of these tasks at the same time, and that's where the Data Cleaner app comes in. You can experiment, try different methods, just like we saw with the live tasks, but all in one place. And just like other MATLAB apps, it keeps track of everything that you did. So when you're done exploring, you can generate the code and use that to automate the process later on. Now, that's not to say we don't care about coding. Even coding is easier in the traditional editor, starting with those code suggestions that you saw before. No need to stop and look at the documentation when you're on a roll. Then let's say you want to edit several variables. You can make a single edit that applies across all the lines you selected. When you're finished exploring and you're ready to make a function, you can select the code and convert it. And once you have that function, you can easily debug it using an inline tool with many options for navigating and updating to help make coding even easier.
With Simulink, our goal is to help you spend as little time and effort as possible to build and edit your models. Like Heather just said, you should be able to focus on your work and not the tools. In other words, we want you to edit at the speed of thought. So with that in mind, we've added a new tool that makes it easier to navigate around your models. It's called the Minimap. The Minimap automatically appears on the lower left of your screen when you pan around your model. At a glance, you can see where you are in the model by looking at the blue box. But then you can click anywhere in the Minimap to go to that place in the model. Or you could drag the blue box around and pan around that way. Once you're done, the Minimap automatically goes away until you pan around your model again. For model creation, we've made a big update to the masking editor. Masks, as many of you know, are what you see when you double-click on a block. And if you create your own custom masks to make it easier to access and change block parameters, I think you're really going to like the improvements we've made. First off, you can now copy a mask from an existing block. That way, you can pick a mask that's close to what you're looking for and then tweak that instead of starting from scratch. When you're creating the icon for the mask, you'll have quick access to the drawing commands so you don't have to remember them all. And if you really want a high level of control, you can now add constraints like restricting parameters to specific data types or values. All right, so we've gone over some things that will help you explore through your designs. Now, as designs evolve, they grow, both in size and complexity, which means you need to scale up your work and collaborate with others. The good news is that both MATLAB and Simulink grow with you as your needs grow. A great example of this is running multiple simulations in parallel. Back in 2017, we released a feature called Parsim that makes it easy to run parallel simulations on your local multi-core machine or on the cloud with a full cluster of machines. It's the same code either way. Parsim automatically takes care of things that you had to code before. Things like file transfer, logging, managing build folders. It could all be done with a few lines of code. But we asked, how can we make this process even easier? Introducing the Multiple Simulations panel. This is a new UI in Simulink for setting up multiple simulations, no code required. Just specify the parameters and variables in the model you want to change for each simulation, and then kick off a job and monitor its progress with the simulation manager. Here it is in action. So you open the Multiple Simulations panel, create a new design study, and then specify which parameters you want to change. If you want to run the simulations in parallel, just check the box on the Run options. Once you activate the design study, the Run button turns into the Run All button, and clicking that starts the job. The simulation manager shows the progress and automatically plots the results as each simulation is completed.
Thinking about those multiple simulations reminds me, if you've ever had MATLAB blocked by some long-running process or code, you're going to love this next update. You can run code in the background through multithreading, which was introduced in the last release. Here's a great example of importing lots of data, which normally would take a long time to run, and during that time, the command line would be blocked. Now you can use parf_eval and other parallel functionality in MATLAB, so the code can run in the background. Then you can continue to work like you usually do in MATLAB, like visualizing data and zooming and interacting with the plot. And you can check the status. Here, the data is still being read. Well, since it's still running, let's just keep going. Here, we're training machine learning models using an app. And once it's finished running, you can use fetch outputs to get the results.
So we've gone over new ways to scale up your simulations and computations. But scale is also about the scope of your design and building up a full model of your system. To do that, MATLAB and Simulink are often used together with other programming languages to design the different components that make up your system. Over the last several years, we've created several blocks to bring in FMUs and C code. Last year, we also introduced a code importer to guide you through the process of bringing in custom code. And this year, in 22A, the C function block now supports C++ code, which further expands the type of code that you can bring into Simulink.
Another big area of focus in language integration is using MATLAB with Python. It's gotten a lot of love over the last few years. As of last release, you can run commands and scripts using pyrun and pyrunfile. This just makes it easier to integrate. You can run Python code from MATLAB now, no matter how it's organized, whether it's a bunch of commands, a script, or a module. And when you're going back and forth between the languages, you can use the syntax you're most familiar with. You can use name equal value syntax to pass arguments throughout MATLAB, including in Python expressions. And when you need to make changes, it's even easier to edit that code. The MATLAB editor now displays Python files with proper syntax highlighting. So you'll see the keywords, strings, and comments, and it even auto-indents and highlights delimiters to help view and edit the code no matter the language. Of course, a big challenge with these integrations is how best to represent your data. We're always thinking about this and improving here, and one of the latest updates is for list and tuple types, which are very generic data types. So you need different options to convert those to the MATLAB type you want. And now you can convert string and numeric data directly. And that's gotten even faster. MathWorks is always thinking about improving performance, and that's even true for the language integrations. This release, you'll notice the type conversions will be even faster, especially with larger multidimensional arrays. Now we're talking about multiple languages, obviously things are starting to get complicated. And as we think about scaling and collaborating, testing code also becomes more important. Of course, unit testing capabilities have been around for ages in MATLAB. It's important to test our own code base. And this improves each release, becoming more and more friendly to any skill level. You can now create a test class right from the tool strip, which gives you a template to help get started. Of course, you also want to see what part of your application have tests or might need testing. There's a code coverage report, and starting in this release, you're going to get even more detailed analysis of that code. You even have metrics for coverage, so you can see whether every MATLAB statement and function are called at least once. Now, of course, maybe this is a little backwards. Usually you want to have requirements for your testing, right? Many of you have been capturing and verifying requirements already for your Simulink projects, and now you can do the same for your MATLAB algorithms and code. You can add your requirements in the editor, customize as needed, or even import them from third-party tools. Then you can link the requirements directly to those unit tests we talked about. You can easily find where those links are missing with a traceability matrix. This will highlight the gaps and walk you through creating those links.
We have something new in the area of requirements for Simulink users too. When you're designing your models, you want to make sure that the actual model behavior matches the required model behavior. So in 22A, we're introducing the requirements table block to do just that. With this block, you can model requirements in Simulink to evaluate logic both before and at runtime. That way, you can identify errors and fix them as early as possible, and be assured that your design requirements are both correct and consistent. So these are just a few of the new ways to scale up your simulations and computations, work with other languages, and develop in a more collaborative way. In this last section, we'll go over how MATLAB and Simulink can help you share all of your hard work.
We spent a lot of time talking about features that we've made at MathWorks, but there are also features to help you make your own features. Users love the live editor tasks we showed earlier, and now you can build your own custom live editor tasks to do whatever you need. This is a great example from Yair Altman, a frequent contributor on MATLAB Central. This task adds to the interactive capabilities for customizing the axis of a figure. So this would be great if you can imagine sharing something specific with your team or your research group, people that you're working with, so everyone can all create the same kind of plots with the same kind of options. These will even show up in the dropdown with the other live tasks. What a great example of customizing and sharing and creating something easily shared with others.
Now, speaking of customization, when we introduced the Simulink tool strip back in 19B, a common question we got was, can I create my own custom tab in the tool strip? Well, I'm happy to report that you can now do this. In your tab, you can add your own custom scripts along with whatever buttons and actions you want to bring in from other tabs. That way, you can access the buttons that you use the most in one place. And if you'd like, you can also share your customizations with your whole team. Now, you may want to go beyond just sharing customizations and create standalone applications and web apps. Integrate into enterprise applications as services, or create standalone simulations that can run in other simulation environments. That's where Simulink Compiler comes in. With Simulink Compiler, you can share your simulations with others, often with an app. To do that, you would create an app in App Designer, write some MATLAB code to access model parameters, and then run the simulation and generate results in an app. Now, you might be thinking, that's great, but I can automatically generate code from my model. So why can't I automatically generate an app from my model too? And you know what? You're right. So in 22A, we've made it so that you can automatically generate an app from your Simulink model without having to write any code. Here's a look so you can see how it works. To create the app, you use the GenApp function in the Simulink compiler. The app is generated, and you can then start the simulation from the app itself. You automatically get access to model parameters and log signals, which you can view in the app. And if you'd like, you can customize the app further, similar to the masking workflow that we went over earlier.
Of course, one of the most important ways of sharing and collaborating is through the cloud. This is not big news, but there are improvements in the community every day. Docker containers are very popular. A container has everything you need to run an application as an isolated process: executable, dependencies, configuration, and data. If you want to put MATLAB in a container so you can integrate with a CI/CD pipeline, for example, there are instructions to do that on GitHub. And in the spirit of sharing, this is also true for different cloud providers. There are many examples, apps, and even Simulink models on the MathWorks GitHub page. But maybe you want to create microservices, which are more like independent services or applications. These are typically implemented as Docker containers, and now you can publish your MATLAB functions as Docker microservices with a few simple commands, then add them to custom applications, web, and enterprise systems.
So let's recap. We covered a lot of ground in the last 20 or so minutes. Editing and navigation improvements to help you explore and analyze your designs. Performance improvements to scale up your designs for production. And new sharing capabilities to bring more people closer to your design.
Now, I know you're super excited to upgrade to the latest version after hearing this talk. And when you do, there's an app to help you. It'll detect possible issues in your code using the latest version. And if you use projects, you can analyze all the MATLAB code and Simulink models in that project and automatically apply fixes to help you with that upgrade.
So Tanya referenced the free on-ramps that are available to learn MATLAB, Simulink, and related products. You can also now take the Simulink Fundamentals training as a self-paced course. Everything is available online or on your local machine if you already have Simulink installed. Thank you, everybody, for watching.
Enjoy the rest of the conference.